30 cool tools that truly go to the next level. Modern tools are no longer just about brute strength or simple mechanical advantage. Today's most impressive equipment blends intelligent engineering, thoughtful ergonomics, advanced electronics, and practical design into solutions that save time, reduce physical strain, and dramatically improve accuracy. Whether you work in construction, fabrication, maintenance, woodworking, electronics, automotive repair, or DIY home improvement, the following collection of tools demonstrates how innovation continues to push boundaries. Each of these tools was designed to solve a real-world problem more efficiently than traditional methods. Some remove physical effort, others increase precision, and many combine both. Together, they represent the next generation of practical equipment, tools that don't just work, but work smarter. Below is an in-depth look at 30 standout tools that elevate everyday tasks to an entirely new level. MAKITA LXD DCU601, battery-powered motorized utility cart. At first glance, the MAKITA LXD DCU601 looks almost playful in its compact form, but it is anything but a toy. This four-wheel, battery-powered utility cart is built to move heavy loads across job sites, warehouses, landscaping areas, and large facilities with minimal human effort. The cart runs on two 18-volt lithium-ion batteries connected in series to create a 36-volt system. This configuration allows the machine to operate continuously for up to 100 minutes, depending on load and terrain. Certain configurations even support 4 batteries, extending runtime further for demanding applications. On flat ground, the DCU601 can transport loads of up to 661 pounds. On slopes as steep as 12 degrees, it still manages approximately 397 pounds, far beyond what most people could comfortably push or pull manually. This alone makes it a significant labor-saving device. One of its standout features is the electronically adjustable flat loading platform. Instead of lifting heavy objects up to waist or chest height, users can raise or lower the platform at the push of a button, from around 19 inches to just over 40 inches. This dramatically reduces strain on the back and shoulders. The platform measures roughly 38 by 25 inches, while the overall machine footprint is about 55 inches long and 29 inches wide. The handle height adjusts between 29 and 38.5 inches, making it suitable for users of different heights. 3 forward speed settings allow travel up to approximately 3 miles per hour, with a reverse mode for maneuvering in tight spaces. A simple trigger controls acceleration, keeping operation intuitive. Additional features include front work light for low-light conditions, rear LED light for visibility, audible warning beeper, swivel lock rear wheels, platform side guards, integrated level gauge for lift height. With a price around $5,600, the MAKITA DCU601 is an investment, but for operations that regularly move heavy materials, it can quickly pay for itself in productivity and injury prevention. Oudubi self-leveling vacuum laser tool. This tool combines vacuum suction mounting with integrated laser projection, creating a unique self-leveling alignment device that sticks directly to smooth surfaces such as tile, concrete, glass, drywall, and polished stone. Using a vacuum system that applies roughly 60 kilopascals of pressure, the unit adheres firmly to surfaces without clamps or stands. Once attached, it can hold loads up to 8 kilograms, making it suitable for supporting itself along with its internal components. A smart control system continuously monitors suction strength and automatically adjusts pressure to maintain a reliable seal, even if surface conditions vary slightly. The laser system projects both a full 360-degree horizontal line and a vertical line simultaneously. Because both axes operate at the same time, users don't need to rotate the tool or switch modes when aligning cabinets, tiles, frames, or fixtures. A built-in circular bubble level allows quick tilt checks in all directions, including on inclined surfaces like staircases. The LCD screen displays suction pressure, load level, battery status. Power comes from a 1800 mAh rechargeable battery that charges in about 1 hour and delivers up to 13 hours of operation per charge. Durability is another highlight. The device is designed to survive drops of nearly 4 feet without damage. Retail pricing typically falls around $113, with sale prices sometimes closer to $99, making it an affordable yet sophisticated alignment solution. Expanded multi-attachment outdoor tool system. Instead of purchasing separate tools for trimming, edging, blowing, pruning, cultivating, and more, this system centers around a single motor unit that accepts a wide range of interchangeable attachments. The power head operates on a 40-volt battery platform and weighs approximately 9 pounds. A variable speed trigger lets users control output depending on the task. Attachments connect using a quick-lock coupler, no tools required. Common attachments include string trimmer with 18-inch cutting path, blower, hedge trimmer capable of cutting branches up to 3/4 inch thick, edger with 8-inch blade, cultivator with adjustable tine width 7-10 inches, pole saw reaching up to 10 feet. Additional accessories are available for snow clearing, sweeping, and surface cleaning. Compatibility with both 18V and 40V battery platforms and certain universal attachment standards makes the system flexible for users who already own other tools. A typical kit with battery and charger costs around $300, making it cost-effective compared to buying multiple standalone machines. MAKITA Cordless Breaker 80V Max Demolition Hammer. Designed for serious demolition work, this cordless breaker delivers the performance of corded models without the constraints of power cables. Powered by two 40-volt batteries working together, it produces up to 72 joules of impact energy at 870 blows per minute. That level of force is sufficient for breaking concrete slabs, removing asphalt, and tackling heavy masonry. It uses a 1/18-inch hex shank for heavy-duty demolition bits and incorporates vibration-absorbing structures and internal counterweights to reduce user fatigue. An indicator light alerts users when maintenance is required. Dimensions: length 35 inches, width 9 inches, height 21 inches, weight pounds with bit. Included accessories typically include a bull point bit and hex wrench. Priced around $2,000, this tool is aimed at professionals who require mobility without sacrificing performance. Leister UNIPLAN 510 Automatic Hot Air Welder. This machine automates the process of welding thermoplastic materials such as PVC and polyethylene, commonly used in roofing membranes, tarpaulins, banners, and industrial fabrics. It melts overlapping edges using a controlled hot air stream, then presses them together to form a continuous seam. Key features: brushless blower motor, brushless drive motor, digital adjustment of temperature, speed, and air volume, preset storage for repeat jobs, automatic material lifting system, guide wheel and caster rail for precise tracking. With a price near $8,000, it is designed for high-volume professional fabrication environments. TBK211 Cordless Soldering Station. This compact soldering station runs on 3 standard batteries and heats from cold to approximately 842 degrees F in just 3 seconds. Temperature is adjustable and a digital screen displays current temperature, target temperature, battery level. It charges via USB-C and weighs under 1 pound. Optional accessories include wire spool holders and small smoke extractors. Cost about $147. Spinner Drive Pro Precision Screwdriver. Machined from CNC aluminum, this screwdriver measures about 3 inches long, 0.47 inches in diameter, and weighs roughly 1 ounce. A fingertip spinner wheel enables rapid screw driving, while a ball-bearing top allows the handle to rotate freely under pressure. Includes magnetic bit holder, 20 steel bits with micro-groove tips, rotating storage cylinder, foam-lined case, price around $80. Slabathor router sled system. Designed for flattening large wood slabs, this system holds a router on a sled that travels along metal rails. Standard rail spacing 41 inches. Working space 30 inches. Rails can be extended for larger slabs. Control options include physical buttons and a mobile app. Price about $1,300. Malco Bender. A manual tool for bending full-length metal roofing panels up to 100 degrees. Compatible with steel, stainless, aluminum, copper, and zinc. Machine metal construction and hard case included. Price $790. Zirocco Hammer Jet Surface Dryer. Uses high-temperature air up to 148 degrees F to dry surfaces without open flame. Powered by a microturbine using diesel or kerosene. Interchangeable nozzles from 8 to 39 inches. Cost about $4,000. WrinGo Electric Sponge Wringer. Fits on standard 5 or 6 gallon buckets. Uses rotating mechanism and nylon rollers to wring sponges to damp condition. Stainless steel housing. Price range roughly $500. FreeForm 360 paint brush system. Transfers weight to top of hand and arm instead of fingers. Interchangeable brush heads and mini roller. Lockable angle adjustments. Price $39. WORX WX392 cordless rotary hammer. 20V SDS plus tool. Drilling, hammer drilling, chiseling modes. Up to 1-inch holes in concrete. Cost $200. Jamesway tool Slitter. Hand-operated panel cutter. Cuts metal up to 24 gauge. Smooth scratch-free cuts. Price $340. QUBE digital level and laser measure. Angle accuracy plus or minus 0.2 degrees. Distance up to 164 feet. Memory 99 measurements. Magnetic body. Cost $70. fastCHECK aircraft surface scanner. Handheld 3D scanner with augmented reality display. Measures dents and surface damage. Battery life till to 4 hours. Used in aviation maintenance. GRABO Vac Drill. Electric vacuum lifter. Lifts up to 375 pounds. Runs 30 minutes per charge. Cost $90. Chawke ultrasonic cutter. 40,000 vibrations per second. 65 watts max output. Multiple blade types. Price $214. MasterFine 360 paint sprayer. Compact sprayer with 2 modes and 360-degree rotating head. Plug-and-play operation. Lift and slide cart. Motorized lift platform. Capacity 440 pounds. Lifts from 10 to 50 inches. Cost $1,399. Bottleloom plastic strip maker. Hand-powered bottle to strip cutter. Titanium alloy body. Price $15. LaserTools pickup tool. 24-inch flexible shaft. Magnetic tip and 4-prong claw. LED light. Cost $20. LaserTools 3 4-inch ratchet handle. 120 tooth gear. Up to 1,500 FTLB torque. Extensions up to 41 inches. Cost $337. Wheel cleaner abrasive pad. 5.9-inch diameter. Half-inch square drive. Cost $32. Hilti P3D 803D scanner. Captures up to 500,000 points per second. Range 260 feet. Cost $53,000. Hilti Nuron VC 4x22 vacuum. 22V cordless vacuum. 8-liter tank. Bluetooth tool activation. Cost $590. Jonard KN-300INS insulated knife. Safe up to 1000 V. Replaceable blade. Cost $31. RYOBI drill pump. Flow up to 10 GPM. Hex shank drill driven. Cost $39. DEWALT cordless deburring tool. 20V battery system. Inner and outer pipe deburring. Cost $219. Arbortech ALLSAW WBA 200X. 60V cordless masonry saw. Elliptical dual blade motion. Depth 4 3/4 inches. Cost $169. VizTool cordless camera rotary tool. Built-in camera. Wi-Fi phone display. Engraving and polishing. Cost $200. Final thoughts. These 30 tools showcase how thoughtful engineering can transform common tasks into faster, safer, and more precise operations. Whether you are a professional tradesperson or a serious DIY enthusiast, investing in smarter tools often means investing in better results, less fatigue, and higher quality work. If you would like, I can expand any individual tool section into a much deeper technical breakdown or create a comparison guide between similar products. When tools begin to think, intelligence, intuition, and the new age of human extension. There was a time when a tool was simply an object. A hammer was a heavy piece of metal at the end of a stick. A saw was a sharpened strip of steel. A wrench was nothing more than leverage with a handle. Tools did not understand, they did not adapt, they did not remember. They obeyed, but something subtle has shifted. Modern tools are no longer passive. They are beginning to observe, adjust, interpret, and in some cases decide. They exist somewhere between machine and collaborator, not alive, not conscious, but undeniably aware in a functional sense. And this transition matters, because when tools evolve, humans evolve with them. We are not merely collecting better equipment. We are slowly building an external nervous system. Let's explore what that really means. From muscle replacement to cognitive partnership. The first industrial revolution focused on replacing muscle. Steam engines pulled heavier loads. Hydraulics lifted what humans could not. Motors spun faster than any wrist ever could. These machines amplified strength. But today's tools amplify something far more precious. Judgment. Look closely at many of the devices in Part 1. A laser tool that self-levels and corrects itself. A vacuum lifter that monitors suction pressure and adjusts automatically. A demolition hammer that senses vibration patterns and balances itself. A 3D scanner that aligns multiple spatial datasets without human input. None of these tools merely do what they're told. They evaluate conditions. They compensate. They self-regulate. This is a fundamental change. Instead of replacing muscle, tools are now sharing responsibility. And responsibility implies intelligence. Not consciousness, not awareness, but functional cognition. Tiny decision-making loops embedded into metal and plastic. The quiet rise of invisible intelligence. Most people imagine artificial intelligence as chatbots, robots, or humanoid figures. But the real AI revolution is quieter. It hides inside motor controllers, pressure sensors, gyroscopes, accelerometers, microprocessors, firmware. When a cart automatically limits speed downhill. When a vacuum tool increases pump power because it senses air leakage. When a laser realigns itself because gravity pulled it off axis. That is intelligence. Not philosophical intelligence. Not emotional intelligence, but situational intelligence. These tools are constantly answering small questions. Am I level? Am I stable? Am I under load? Am I slipping? Am I overheating? Am I aligned? Every second. Without your permission. Without your awareness. They form a silent partnership with the user. You act. They adapt. Together you perform. Why this matters more than speed. Speed is nice. Power is nice. But the deeper value lies elsewhere. Human error is the largest source of material waste, tool damage, job site injuries, project delays, rework, fatigue. Smarter tools reduce error not by making people perfect, but by absorbing imperfection. A human hand shakes. A laser does not. A human forgets to check level. A self-leveling system never forgets. A human misjudges load weight. A motor controller measures torque precisely. This creates an invisible safety net. Not a dramatic one. Not a flashy one. But a constant one. Like guardrails on a mountain road. Most days you never notice them. But the day you slip, they save your life. Tools as memory containers. Another quiet evolution. Tools now remember. They store preset temperatures, preferred speeds, last used modes, measurement histories, calibration profiles. Some even store usage logs, error codes, maintenance cycles. A tool that remembers is fundamentally different from a tool that forgets. Because memory creates continuity. It creates identity. It creates context. Your tool slowly becomes tuned to you. Not in an emotional sense, but in a functional sense. It knows how you work. It knows what you tend to select. It knows your defaults. This is the beginning of personalization at the hardware level. Not software personalization, physical object personalization, which is astonishing. The shift from holding to guiding. Many modern tools are engineered around a philosophical change. Instead of forcing your hands to do everything, they shift your role toward guidance. Consider router sled systems that move themselves, brush systems that rest on your arm instead of your fingers, carts that lift and slide loads automatically, ultrasonic cutters that slice with vibration instead of pressure. Your hands no longer provide raw force. They provide direction. This mirrors what happened in aviation. Early planes required constant muscular input. Modern planes are fly-by-wire. Pilots suggest. Computers execute. We are witnessing the same transformation in handheld tools. From muscle-driven interfaces to intention-driven interfaces. This frees mental bandwidth. You stop thinking about holding steady and start thinking about where should this go. That shift unlocks creativity. The psychological impact of effort reduction. Reducing physical strain does more than protect muscles. It changes psychology. When tasks feel heavy, people avoid them. When tasks feel light, people explore. This is subtle, but profound. A worker with a manual sponge bucket cleans only what is necessary. A worker with an electric wringer cleans more thoroughly. A person with a heavy lifting burden cuts corners. A person with a powered lift focuses on placement precision. Effort shapes behavior. Behavior shapes outcomes. Therefore, reducing effort raises quality. Not because people become better, but because they become less tired. Fatigue is the hidden enemy of craftsmanship. Modern tools are slowly erasing fatigue from the equation. And that is revolutionary. Tools as confidence multipliers. Confidence changes everything. A hesitant worker moves slowly. A confident worker moves fluidly. Smart tools create confidence by offering predictable behavior, consistent output, visual confirmation, automatic correction. When you trust your equipment, you stop second-guessing. When you stop second-guessing, your mind quiets. When your mind quiets, your attention sharpens. This produces a strange loop. Better tools, right arrow, calmer mind, right arrow, better work, right arrow, higher trust, right arrow, even calmer mind. Over time, the user grows alongside the tool. Not just in skill, but in composure. The hidden philosophy of modularity. Many modern systems revolve around interchangeable attachments. One motor, many functions. This is not just economical. It is philosophical. It says, the core is stable, the identity is flexible. Just like humans, you have one brain, many roles. Parent, worker, creator, student, friend. A modular tool system mirrors human adaptability. It suggests a future where tools are platforms, not products. Platforms invite ecosystems. Ecosystems invite innovation. This is why attachment-based tools spread rapidly. They feel natural. When measurement becomes a sixth sense. Laser distance meters, angle sensors, digital levels, 3D scanners. These devices give humans something evolution never did. Instant spatial precision. Your ancestors survived with approximate geometry. You can now hold absolute geometry in your palm. You know, exact distance, exact angle, exact depth, exact alignment. This is not merely convenience. It is the birth of a new sense. Call it technological proprioception, the sense of space through machines. Once you experience it, raw estimation feels primitive, like trying to navigate without sight. The convergence of trades. Another interesting phenomenon. The boundaries between trades are dissolving. A carpenter uses scanners. A painter uses laser alignment. A mechanic uses thermal sensors. An electrician uses ultrasonic cutters. Tools are no longer trade-specific. They are capability-specific. This creates hybrid craftsmen. People who combine disciplines. Wood plus electronics. Middle plus software. Construction plus data. future tradesperson is not narrow. They are polymaths with tool belts. Why simplicity still matters. Despite all this complexity, the best tools still feel simple. Press button. Pull trigger. See result. This is intentional. True sophistication hides itself. Bad design shows off complexity. Good design disappears. The user experiences. I did that. Not the machine did that. This psychological ownership matters. Because humans need to feel agency. Tools that steal agency feel threatening. Tools that amplify agency feel empowering. The difference is everything. The illusion of control and why it's useful. In reality, many modern tools are doing far more than the user realizes. They are compensating, filtering, correcting, predicting, but the interface presents a clean illusion. You are in control. This illusion is beneficial. It preserves dignity. It preserves learning. It preserves pride. People do not want to feel replaced. They want to feel enhanced. The best tools understand this. They never announce their intelligence. They simply perform. Quietly. The road ahead, tools that anticipate. Where does this lead? The next phase is anticipation. Tools that detect material before cutting, adjust speed before resistance increases, warn before mistakes occur, suggest better approaches, learn from past jobs. Not robots, not autonomous builders, but anticipatory instruments. Like musical instruments that tune themselves. Like cameras that focus before you notice blur. Like brakes that engage before skidding. Subtle, preventative, supportive, a philosophical closing thought. Every major leap in civilization came from better tools. Stone, bronze, iron, steel, electricity, computing. But what's different now is that tools are beginning to reflect us. They sense, they adapt, they remember, they respond. In a quiet way, we are embedding fragments of our cognition into matter. Not to replace ourselves, but to extend ourselves. Your hammer no longer just strikes. Your level no longer just balances. Your cart no longer just rolls. They participate. And when tools participate, work transforms from struggle into collaboration. Part 2 is not about gadgets. It is about a shift in the relationship between humans and objects. From master and servant to partners, and that partnership is only just beginning. The psychology of mastery, how great tools quiet the mind and awaken skill. There is a strange moment that happens when someone uses a truly great tool for the first time. Not a pretty good tool, not a good enough tool, but a great one. The moment is quiet. No fireworks, no announcement, just a subtle internal shift. The user stops fighting the object. The shoulders drop. Breathing slows. Movements become smoother. And suddenly, the person realizes something. I'm not wrestling with this anymore. That realization marks the beginning of mastery. Not mastery of the tool. Mastery of the interaction between human and tool. This part explores that invisible space where psychology, ergonomics, feedback loops, and design converge to transform effort into flow. The hidden tax of friction. Most people underestimate how exhausting friction really is. Not just physical friction, cognitive friction, decision friction, micro frustrations. Every time a tool slips, vibrates excessively, requires readjustment, loses alignment, overheats, needs repositioning, it charges a tiny mental tax. Individually, these taxes feel insignificant. Collectively, they are devastating. They drain focus. They fragment attention. They break rhythm. Great tools reduce friction not by being perfect, but by being predictable. Predictability builds trust. Trust removes mental guarding. Mental guarding consumes energy. Remove the guarding and energy returns. This is the first psychological gift of excellent tools. They give your attention back. Why flow is rare and precious. Psychologist Mihaly Csikszentmihalyi described flow as the state where challenge and skill are perfectly balanced. Too easy right arrow boredom. Too hard right arrow anxiety. Flow sits in the narrow channel between. Poor tools push tasks into the anxiety zone. Great tools pull tasks back toward the flow zone. Not by removing difficulty, but by removing noise. Noise is anything that does not directly contribute to the goal. Vibration noise. Setup noise. Recalibration noise. Uncertainty noise. When noise disappears, the brain hears the task clearly. And when the task becomes clear, flow becomes possible. The tool as a teacher. Great tools do something surprising. They teach. Not through instructions. Not through manuals. But through feedback. Consider. A well-balanced hammer tells you when you strike correctly. A sharp blade tells you when your angle is right. A laser level tells you when alignment is true. A vibration damp drill tells you when pressure is optimal. The tool becomes a feedback instrument. Like a musical instrument. A violin squeals when posture is wrong. It sings when posture is right. Tools speak. Not with words. With sensation. The more refined the tool, the clearer the language. Over time, users internalize that language. They no longer need the tool's feedback. They become the feedback. This is how craftsmanship is born. Why cheap tools create bad habits. This is uncomfortable to say, but important. Low-quality tools often train users incorrectly. They require excessive force, compensating angles, awkward postures, over-tight gripping, constant correction. The user adapts to the tool's weaknesses. Those adaptations become habits. Then when the user encounters a good tool, they still carry the bad habits. The tool feels strange, too sensitive, too light, too smooth. But the truth is, the good tool is honest. The bad tool was lying. It forced the user into survival mode. Great tools allow the body to return to its natural mechanics, which often feels unfamiliar at first, like standing upright after years of slouching. The moment you stop thinking about the tool, one of the clearest signs of mastery, you forget the tool exists. Your attention shifts entirely to the work. The cut, the surface, the line, the joint, the finish. This is not accidental. It is the result of ergonomic shaping, balanced weight distribution, intuitive controls, consistent response. When interface friction drops to near zero, the tool becomes transparent. Philosophers call this ready-to-hand technology. It fades from awareness. Only the intention remains. This is the highest compliment a tool can receive. Muscle memory is really nervous system memory. We say muscle memory, but muscles do not remember. Neurons remember. Your nervous system stores movement patterns. Every repetition strengthens a pathway. Great tools create clean pathways. Sloppy tools create noisy pathways. Once a pathway is established, it is hard to erase. This is why early experiences matter. A beginner who learns with stable, predictable tools develops clean neural patterns. A beginner who learns with unstable tools develops compensatory patterns. Over years, this difference becomes enormous. Two people may have equal time in a trade. One moves smoothly. One fights constantly. The difference often traces back to tool quality. The confidence-skill feedback loop. Confidence is not arrogance. Confidence is expectation of success. Expectation shapes behavior. Behavior shapes outcome. Outcome shapes confidence. Great tools enter this loop gently. They increase success probability. Success builds confidence. Confidence relaxes the body. Relaxed bodies move more precisely. Precision increases success. The loop strengthens. Poor tools reverse the loop. Failure, right arrow tension, right arrow errors, right arrow more failure. This is why some people seem naturally talented. Often, they simply encountered good tools early. Why ergonomics is not luxury. Ergonomics is often treated as comfort. A soft grip, a curved handle, a padded surface. But ergonomics is actually about biomechanics. How force travels through joints. How tendons glide. How muscles fire. Poor ergonomics cause microinjuries, nerve compression, Tendon inflammation. Joint misalignment. Pain forces attention inward. When attention turns inward, performance drops. Great ergonomics keep attention outward on the work. This is not indulgence. It is performance engineering. The subtle role of weight. Weight distribution matters more than weight itself. A heavy but balanced tool can feel lighter than a lighter but poorly balanced one. Why? Because your muscles do not fight torque. They simply support mass. Torque creates constant corrective effort. Corrective effort equals fatigue. Great tools feel neutral. They sit where you expect. They move where you intend. This neutrality is psychologically calming.